Hello, and welcome to yet another notional pipe stream in which we'll continue to investigate componentized rigging concepts and how to use them with contour rituals. First of all, I did want to mention something, which is, and this may not be a surprise to people who are watching this stream right now, I screwed up the time on the YouTube, the YouTube like scheduled stream thing so that it said it was yesterday. If you showed up yesterday and nothing happened because that's not actually when it was supposed to happen and I didn't even realize that, then I apologize because that was not intentional. But anyway, regardless, thank you for showing up now. And I'll try not to make mistakes like that in the future. Anyway, we were going to investigate using doing a componentized spine today. But before we do that, actually, because as you may recall from last time, if anybody watching this watched that too, we like I actually had a partially done spine from earlier that I was going to continue using, but hadn't quite remembered where I had left off. I then looked at it and remembered where I had left off, and I actually think that it makes sense for us to start with making an alteration to the fingers, because it will lead in well to what we would be doing with the spine. And specifically, that's about having the guides pass in the correct data into the component. One of the things about these components is that while the components themselves certainly don't have to, a lot of them do sort of make the assumption that your controls are aligned down some axis, right? That would be a pretty normal thing. And it's pretty essential, for instance, for IK. It's not really essential for anything else. You don't have to have that be true of a finger, for instance. But it often is, and it's usually a good idea. So you could, of course, also have components that don't expect their inputs to be aligned in any particular way. So, that's, so the way that we did that for the fingers, and actually, let me just bring these two things up to refresh anyone who, didn't see that or, doesn't recall something that happened, vaguely. We discussed, very briefly last time. Let me just bring up the arm. As you may note, for instance, as I pull the guides around in the arm and change its proportions, it is automatically arranging itself so that it maintains itself on the plane. Like the orientation of those guides stays on the rotate plane that the IK of the arm will need. And I just set that up with a few constraints. It's sort of a default, right? The guides themselves don't really care how they're allowed to move around. They're just going to pass their data into in the form of world space matrices into the component, so you're free to parent them and constrain them and do whatever else you want in order to keep them in the configuration you want them to be in. So in this case, I had set up some constraints to maintain them in the arrangement that they need to be in for this component to make sense. And I have done something similar for the fingers, but in an entirely different way. So if we go take a look at our finger again, in the case of the finger, what I did was I parented all of these, but I'm not allowing them to be moved along any but one axis. And that's kind of a hack, right? So the intent here is that because only translate X is available, right, you can rotate it any way you want, but you can only translate them down translate X in order to keep them aligned sort of in a chain-like way. But that's not necessarily the desirable sort of interface for the user, right? It would be better if you could select this and just sort of move it anywhere you wanted to. And there's no particular reason you can't do that. I just set it up this way when we were initially making the finger because it was convenient and I didn't really want to go into that whole question, immediately. So I think the first thing for us to do is actually to fix that aspect of the finger, and allow it to essentially point down, ensure that the guides will continue to point down X like they're supposed to. So, that said, I should probably at least raise the question, sort of bring up this question beforehand. of whether this is in fact the right thing to do, which I think it probably is in this case, but I want to bring up some of the reasons why it might not be, right? Like it's not guaranteed to be. And that a lot of that has to do with the question of what the component is responsible for. So in this case, for instance, you could argue that the component should be able to receive any set of world space matrices from as inputs and should do its own work to make them compatible with what the component needs to do, and that having any real requirements for the matrices at all is pushing some of the responsibility that the component has for operating properly sort of out to something outside the component. And actually, I pretty much think that that's kind of correct. Actually, like arguably, you really kind of shouldn't do it this way. You shouldn't require that the component, the guides to the component should do any particular thing. The component itself should be responsible for its own behavior and its own needs. The reason why I'm not doing that is that it's a pain, right? Like, yeah, honestly, if this were something that we were writing as code, and it was fairly easy to just have a function in there, like, chainify inputs or something, and, run through all the inputs and do that, and, like, have a for loop that does that or something, I would just be like, yeah, actually, the component should be responsible for this. Because that's not the case, because we are using the Maya node graph, doing things in that way would make things more complex. Right? Either we would need to have a whole bunch of additional nodes inside the component, and those nodes would have to do a variety of things that there aren't, like, nodes in Maya to do, like, doing aims and stuff. You have to make it out of nodes, and, certainly that's possible to do, but it adds additional complexity to your rig. And then or you would need to establish some sort of extra transforms inside the component, which you could constrain. Also adding additional complexity to the rig of a different kind. And either of these things is, I think, sort of also undesirable, right? I want to keep things as simple as they can be. I don't want to end up adding a lot of additional complexity. And so the decision that I've made is to say, we have two things, neither one of which is the most desirable situation. I'm going to choose the one that adds less complexity. Because complexity in rigging is generally a bad thing. Like, we want to reduce complexity. That's a very good goal, right? And honestly, though, you could go either way. And like I said, if this were like a piece of software where you had better tools for this, because, like, the other thing you could do, and I should mention this, because, like, we talk about how the Maya node graph has no tools for abstraction, and, of course, the componentized system is itself imposing some tools for abstraction. That's kind of what it is, right? You could make that a subcomponent, right? You could abstract it that way. But again, because that's not native to Maya, you're just increasing complexity. So, like, I basically made the decision, yeah, okay, we're going to do something in this particular case, this particular implementation of componentized rigging, where we're going to have some assumptions about what you're allowed to pass in terms of guides. And even if that's not the most desirable thing, like, it has some questionable consequences, I think it's the right thing to do here because I want to limit complexity as much as I can. I'm sort of curious what you think about that, Tagore, actually, because it does mimic a lot of the problems that we encounter in software a lot, where I actually think that what I'm doing here would kind of be the wrong thing to do.
Well, I mean, I don't know. I'm not sure that I'm not sure the analogy completely can be made here. Because you are doing it through the Maya interface.
Right, I am. It's true, but it's like, let's say you had a function that was calculating the result of this rig, right? And you were allowed to pass it any matrices as arguments. It would make a certain amount of sense to validate those matrices or simply transform them into the state they need to be in, rather than passing the responsibility of making sure that they're aligned correctly to whatever calls the function, But maybe not. Like, maybe that would actually be perfectly reasonable. Anyway.
I mean, I think it really depends, actually.
Yeah.
Here's one thing, which is that there tends to be overhead. So there's a lot of considerations there. There tends to be overhead to doing that kind of validation, right? So if you are very confident that you are never going to make a mistake, then if you're writing performance critical software, you may not really want to be doing that, because there may at least be situations in which you can be very confident in that, where something's going to get repeatedly called with the same matrices, right?
Yep.
And so you're going to be redoing a whole bunch of work that could have been done once at the caller position. On the other hand, if you're not sure where the matrices are coming from, then you almost certainly want to validate them. So I think it's a little bit situational.
It is, and arguably, you could say actually that this situation is analogous to that one. Although the question isn't performance, it's complexity, and it's which of course does have performance implications. That's not the primary reason why I want to avoid doing it.
Well, one thing, we've talked a little bit about contracts, for instance, right?
Yeah.
Like racket contracts, et cetera, et cetera. And one of the things about that kind of thing, where you have assertions at least, right?
Mm-hmm.
You're not fixing stuff up, but you are at least asserting, like, this is true, this is true, this is true in the code. And then when you make a production build of it, you flip a switch and those assertions go away, right?
Right.
So that they don't cost you anything when you actually release the production thing. But when you are in development, you can see if this actually ever happens.
Indeed, right, sure, you might do something like that. And of course, part of the problem here is there's no such thing as validation in this context. Like, you can't have a rig component throw an error. That's not a thing, right? Like, you just have to try to, you have to either make it work properly or assume that that the data you're getting is correct. Anyway, we've ranted about that particular subject long enough. Let me sort of proceed with what I'm doing here. So I basically had these in a hierarchy for the purpose of essentially forcing them to be in a chain, as it were, to be aiming down X. And I'm now going to take them out of that hierarchy. The first thing I did was to put translate Y and translate X back, because obviously if translate Y and Z were locked and I unparented all of this stuff, actually in this particular case they're all in a line, so maybe it would be fine, but generally speaking probably wouldn't work very well, right? Because what we actually want for these guides now is for these things to sort of float around, and then you can move them around wherever you want. And as you can see, this is currently not actually working. This is going to relate directly to what we're going to be doing with the spine shortly. That we are not aiming down, like the reason why none of this is aligning properly is that no orientation here is changing. We're simply allowed to translate the thing, but we are using the distance between these things to define the bone length. But its distance doesn't imply anything about rotation. So what we're going to do here is to make each one aim at the next one along the line. Except for the base, which can just sort of like be sort of free floating. Actually, no, sorry, the base needs to aim too. But that does raise the question, like, which direction is up? And I think that what we are going to do here is to assume that it's the parent space that these guides are in, whatever that may be, right? So you can, of course, because the guides are passing along world space matrices, you can choose to parent them to whatever you want, right? You can parent all the guides to something, it doesn't matter. And in this case, in our final thing, we may end up parenting these guides to the hand, for instance. That would make a certain amount of sense. You want to move the hand around, and then you have the ability to move the fingers around. Or we may want to add a sort of, and I think this is actually what we should do. This is what we should do. We should add a finger mover guide, right? And that's not really a guide. Like, it's not passing any data into the system, but it will be desirable to have the ability to just move the finger around wherever you want it to be. And so I'm going to go ahead and do that now. Now, its appearance right at the moment is just going to be I'm going to call it all. How about? Because it's going to get a namespace, right? Left finger all guide, something like that. And for the moment, I am just going to make it a slightly larger. We can figure out what its appearance should be later. It shouldn't be this, right? But I'm going to make it a slightly larger, a slightly larger locator with like a different color. Like, for the moment, I think that'll be fine. You set locator colors. Oh, that's right. It's not a specifically locator thing. It's just drawing overrides. All right, so this is a different one, and I'm actually going to do what we did for the setup machine way back when, which is to say, if you want something to move the whole finger around, you probably want it to be at the knuckle, actually. Like that's sort of the best place to have a mover that moves the whole finger. And then I'm just going to ensure that joint 1 is actually zeroed out, because that's what it should be. And then I'm going to go ahead and parent all of these to all. Now, this actually has quite a nice consequence. So, we can move them around. Note that in this case, rotating them has an effect. Whereas in this case, it does, well, I mean, it does, but not necessarily the effect that you'd expect, right? And translating them certainly doesn't. Whereas in this case, translating them does actually behave as one would expect it to behave. So now we can actually use this really nice quality that aim constraints actually have. This is something that we've actually talked about a bit on this stream. The fact that there is actually a way to use aim constraints to do a rotate onto that does not require an up vector. Because one of the biggest questions you'd have is which direction is up. In the case of the arm, this wasn't an issue. Because simply, and you can also do this with constraints, simply knowing the 3 points, like hand, shoulder, and elbow, that forms a plane. So you always know what the correct orientation for these guides is, and it's sort of, like, you don't need to know anything about the world. You don't need to know anything about the, you don't need an up vector. You don't need to know anything about the space the guide is in. In this case, there isn't, like, for a finger, no such thing exists, right? Fingers aren't going to get IK, at least for these rigs anyway. So all we need to do, this is actually quite nice. Oh, that's right. When I parented them, I always forget this. When I parented them, they all took on the same color, because I did my drawing overrides on the transform node rather than the shape node, which is what I meant to do. That's better. So, and to be clear, the reason why I needed to put them under some transform before I did this is because its parent space will matter for the behavior. So, got joint 1, going to make a constraint. Its aim vector will be X. And its rolled up type will be none, and that's the important part. Because we, now watch this. As I move, base now has the constraint. As I move joint around, base is aiming towards it. Here's the interesting part about this. Normally speaking, you're going to get, I mean, this is a classic issue that people encounter when doing twist, right? You go past 90 degrees on one axis and you're going to get an issue. Watch this. I can go past 90 degrees on any axis, I will not see an issue. The math of sort of rotate onto works out very nicely for that. It's also how when I'm not using contour, which calculates twist internally, of course, how I calculate twist joints. It is very stable. It is very effective. It's an option right here in Maya's aim constraints, and people generally don't know because Autodesk never really advertised that, I guess. It's very frustrating. Otherwise, this would all have been considerably more complex. Yep, there we go. Now you can simply translate these things anywhere you want, and they are properly passing that data through to the component. And if we want to look at how this works in the context of our body plan, let's go take a look at that. Now, of course, one of the nice things here is because this is all live, right? You know, these are all references. We just made a significant change to one of the rigs, and that was perfectly fine. I mean, not that we had actually attached anything yet here, I guess, but it's not going to be any sort of issue. All of these, no rebuilding was necessary. All of these arm guide things get an appropriate, we'll just get the reference and we'll do what you would expect. You can just sort of change it live and it's not a problem. As long as, of course, if you obey the rules of giving the right things into inputs and outputs. So I'm going to take the alls, and I'm going to go position them at the end of the hand. I guess thumb goes over here. pointer, middle ring, pinky. Not, you know, the best arrangement of fingers ever, but will fit, you know, these will be fit to some actual character, and therefore we don't really care what they look like right now. Let's take a look on whether I had already set up. Yeah, I didn't actually. I didn't actually hook up into all of their parent space thingies. So let me do that real quick. What am I doing? Hypershade. That is not what I meant. I meant node editor. I have been doing this for so damn long that I reflexively still sometimes open the hypershade, because there was a time before the node editor when all you had was the hypergraph, and the hypergraph was not necessarily a great way of looking at your scene connection. And so what you often ended up doing was actually using the hypershade to rig. Like, I am not even making that up. That's what we used to do. And I've been doing this for so long that occasionally I reflexively open up the hypershade when there is no longer any reason to do so. And I'm going to write a little bit of code for this, I think, because we now have enough things that we want to hook up to an anchor, right? You know, we each one of these things has an anchor. It needs to be controlled by the hand. That doing it manually becomes very irritating, right? And I'm going to do it manually once first, because as a refresher, basically, for how this works. We've done it manually up till now, but I think I'm reaching my limit for that, you know? Here's what we would do. We get, in our components, we get the ARM guides. Sorry, we get the ARM inputs and outputs. Apparently I can't talk today. And we get, say, for the pinky. Oh, right. I'm looking at the guides there. We get the pinky's inputs. And actually, what we have to do here actually isn't all that bad. I'd sort of forgotten, like, you know, how much of it was handled inside the component. But all we need is the output of the sort of the rigged position, potentially the animated position of the hand, i.e. the left arm hand output. We need to put that into anchor, and then we need to put our left arm inputs into anchor hand into anchor offset. And that should now mean that the finger moves around with the hand, and indeed it does. And for a fuller explanation of that, of how that system works, you can watch the last time stream. So let me go bring in the next one. I mean, I actually am going to do this by hand because it's actually simpler than I had recalled. I basically am going to use the same things. I just need multiple inputs. Did it actually hook up itself into the right thing? Yes, it did. Sometimes the node editor's behavior can be a little mysterious. I'm just checking. Yeah. I guess it's because it's the only available connection. All right, this should work now. Yep. And, you know, as before, not that this is news. I mean, this is how the system's always been designed to work. But I can now change the proportions of the rig, whether or not the rig is in bind pose. Although generally speaking, you would want the rig to be in bind pose because you're going to have to rebind. And in the case of Contour, you'll have to enter rebind mode in order to do that. So, Now I think it is time for us to move on to the spine. The reason why I was bringing all of that up is that I realized that that's where I had left off when building this spine. I had left off at the point at which I had hooked up a bunch of this stuff. Like, as you can see, if I rotate the spine, for instance, it does in fact take the joint with it. It's outputting the right stuff to the right places. What it is not doing is handling the relationships that the guides have to each other. So if I go and translate this guide, it's going to pull the distance off of it, and it's going to propagate that properly to the bones and joints. But obviously, it doesn't actually assume the correct orientation. So first things first, I'm thinking that we maybe actually want to make it, and we did this for the setup machine as well, we may want to make it a general principle for these guides that we are going to add a parent to them. That lets you reposition the entire thing, or potentially scale the entire thing. That is also potentially an option. One of the things that actually is going to be interesting coming out of this rig is it will actually be scalable. It's actually, like, Contour makes that absurdly easy. It'll actually sort of be scalable, probably, without us having to do much of anything at all to make it that way. I'm going to call this all. And I think that the naming convention we started to establish for the others is that we don't put underscore guide in there, because they are under the guide, so we already know what they are. And if we want to do anything to script around them, we're not going to rely on their name anyway. Let's make all larger. There we go. Like I said, we were going to replace this with some other appearance at some point. I mean, this won't be what they actually look like, but this will do for now, having something that we can work with. Once we think that this is under a consistent parent space, we can simply do the same thing we did before. I mean, we're doing it in a little bit of a different order though, because the spine operates a little bit differently. What the spine is actually going to how it's actually going to behave is it's going to be very much like a Schleifer spine, right? It's going to have, two controls at the bottom and top. They're going to be independent. I mean, there's going to be some sort of upper body control as well. But that's not necessarily going to be part of this component. One of the nice things you can do with components is sort of decide how you want to chunk up your rig. And in this case, the upper body control is just going to be its own special component so that it can sort of pass data to various things it might need to pass data to, including the spine, but not limited to the spine. And that's especially true because in the case of the arm, for instance, and when we get to the leg, we'll be setting this up. In the case of the arm, we're actually establishing spaces for space switching purposes, something we didn't need to do for the finger. And that we don't need to do for the spine as well. I mean, we could do that for the spine if we really wanted to, but it's not really, I think, an essential feature. But because we are going to need to do that, and it needs to get data from the upper body control in order to do so, passing that all through the spine seems unnecessary. So it sort of makes sense in terms of how you chunk the rig up, what sections you do, to have the upper body control be like its own component. So we're not worried about that right now, basically. Let's see, what do we have here? Right. So first things first, let's aim the pelvis not at the mid-spine, but at the chest. Immediately, we start getting something much more like we would expect, right? Because we were already controlling the length of the bone based off of the distance between the chest and the pelvis. And the fact that we are now also orienting them correctly just already works properly. It is not, however, sufficient for us to get what we want out of this. Let me just undo this. One of the other things to note about these guides, they are not under buffers. We could put them under buffers, actually, if we wanted there to be a canonical arrangement of them. And I'm not actually doing that, and the reason why I'm not doing that is I'm not sure that there even is a canonical arrangement of them, if you see what I mean, right? Like, this isn't a case where there is a default that you want to be able to return to, that you want to be able to zero to. This is what sets the default. So I don't really think it makes any sense for it to have a default of its own. But as a result, you end up, like, if you go pull it around or wherever, you can't just zero it to have it go back. You have to undo. This here, the mid-spine, this is going to control a bone CV, which we don't, as yet, actually have. So I'm going to... Alright, I'm going to disable the radius indicator, I think. What the heck did I just do? Alright, anyway. I'm going to add a bone CV. And then I'm going to take a look at, and here's another way in which Contour is going to make this pretty easy for us. I'm going to take a look at the bone CV socket. Now, the bone CV socket has as its rest position, this is what defines the rest position of the bone CV. Now, I'll just note about doing this in Contour that the rest position of the bone CV does not, this bone CV socket, it's not actually essential to the behavior of the bone CV. You are allowed, for instance, to parent the bone CV to other things if you want to, and there are plenty of cases in which one might. But in this case, there's no particular reason to do so. We can simply drive this rest position. We can say that just like we are controlling other aspects of this rig with the inputs that we're receiving to the rig, we're receiving from the guides, we can do the same thing here. And it's actually going to be quite easy because what these translate values actually are literally just the rest position of this bone CV socket in the space of the bone. And we already know what that is. That's what's coming in from the pelvis guide. So in order to know what the right thing to do here is going to be pretty easy. Here's all we need to do. We have done it before on multiple occasions. We need to have the bone CV socket. We need to bring in the inputs, which I believe have mid-spine already as an input. It should, if it does not, it does. Yep. Seems like I did set this up for space switching, actually. Because I've decided, at least for the moment, not to do with that with the spine, I may actually get rid of some of these. Anyway, here are some inputs. And we need to get the mid-spine. And we need to put it in the space of the pelvis. Specifically, the inverted pelvis. Now, of course, it will not let me pull out the mid-spine pin because this is the node editor. I somehow managed to screw that up. There we go. As we were discussing previously, what we are doing here is taking the... I'm sorry, this shouldn't have been pelvis overshoot. That should have been pelvis. Actually, I'm, again, sorry. That should actually have been mid-spine. There we go. That should be correct. We are taking the world space matrix of the mid-spine from the guides. We are multiplying it by the inverse matrix of the pelvis, which means that we're essentially getting its transformation relative to the pelvis, which should be exactly what we need to plug into Contour Bone CV Socket 1. Let's find out if I'm right about that. But we will need to decompose. What am I doing? Of course it doesn't get plugged into Translate. I don't even think Translate does anything for those. Force of habit. Rest position. That's what we want. Does this do what I expected it to do? Seems to be... Let's find out. Yes, it does. That is what I wanted to see. And that should continue to work as we move this around. And indeed it does. With the exception, of course, that we would want this mid-control to be suspended between the other two. Also quite easy to do. Again, we're allowed to do anything with the guides that we want, including taking the mid-spine, parenting it to the pelvis. And in this case, we actually are going to give it a buffer. Although this buffer will simply serve to reposition it relative to something else. And we will call this mid-spine suspended. We will give it a point constraint. The reason why it's parented to pelvis is so that it takes on pelvis's orientation. And then we parent the mid-spine guide to it. There we go. We can essentially set the top and bottom placement of the spine guides, and then we are free, if the spine ought to be curved in its bind pose, to curve it. All right, so we now have what should be, well, it's very close to being a working spine. It's not quite there yet because we don't have any actual control set up for it. In fact, I'm not sure that this nerve circle here actually does anything. Let's see if it actually does do anything. Pretty sure it, in fact, does. Yeah, it very clearly does not do anything. So what are we driving? Here's the joint socket. The joint socket's being driven, which makes perfect sense. Actually, right, so we need this control. We actually maybe don't drive the joint socket, actually. Let's instead drive this bottom control, this pelvis control. And we will buffer it. And we will place it under the anchor as well. Now, all of these incoming connections to the joint socket, we want them to be, actually, we want the pelvis buffer to be driven by something slightly different. So actually, I will simply disconnect the joint socket. I'm going to break these connections. But also, I want to make sure, because I probably drove shear 2, indeed, which was the correct thing. I want to make sure that's also broken. All right, so here's what we're going to do with the pelvis buffer here. We are going to drive it off the pelvis. And in fact, we don't need to do anything particularly complicated there. That's simply a single decomposed matrix. Because that's, that is simply taking we don't need to put it in anything else's space. Let's take a look at the inputs. We've got the pelvis right here. We're going to have to do something else with pelvis overshoot in a minute. Decompose matrix. We just plug that right in. It doesn't know what that is somehow. And got to plug your translate rotate scale in. Did it know that that was scale? It did, in fact. But it did not know that that was shear. There we go. Now, this orientation that it has suddenly taken on, this is the correct orientation. One of the things that I'm doing here is trying to ensure that everything points down a consistent a consistent direction. And not everyone necessarily does this. You definitely do see a lot of rigs where, say, the spine points up Y, because people are familiar with that. They're like, oh, Y is up, right? Whereas the arms point down X. I actually prefer to maintain complete consistency in the direction that controls and joints point. I would much rather have everything point down X, even if that means, well, or I mean, I don't really care which axis it is, but as long as it is the same axis, regardless of what the how the actual component is oriented. So in this case, what this actually means is this control here should not have its circle pointing down X. We can just go in here and say no, pointing down Y, point down X instead. This will be correct. So here we've got our pelvis control. We're going to parent the joint socket to it. This may start looking familiar to anyone who has, looked at some of our other streams about rigging with contour. Let's take a look at what we need to do for this joint socket, though, because we do need to do something else with it, which is that we do have this idea of pelvis overshoot, where you want the ability, and right now you can already see this is doing the wrong thing, right? But you want the ability to position an overshoot for the pelvis because of the sort of spline over excuse me, spline overshoot aspect that you want in your contour rigs, so that you'll get nice contour deformation around the joint. And in order for that to be calculated, there has to be a spline running through the joint. So this is, again, if you've seen any of our other streams where we rate stuff in contour, not going to be terribly surprising that this is how this works. In this case, we need to constrain the pelvis overshoot guide to point at the pelvis, because just like everything else, if you move it around, you need to get its orientation lined up. Let's see, I believe, yeah, pointing down X will always be correct in this case. Yep, there we go. This doesn't change any. Now, of course, this is all completely wrong because we are not yet driving the joint socket with this guide's orientation. But let's do that now. I want to get inputs. This is going to be the pelvis overshoot input. And we're just going to do the exact same thing we did before. This thing that I really should script because I don't like doing it by hand, but maybe I won't script it right now. Let's see, we need it in the space of pelvis, therefore pelvis will be inverted. And we need to do a mult matrix. Which will have pelvis overshoot as its first item, and the output of this inverse matrix as its second. So again, what we are doing here is we are putting the we are putting the output matrix of the pelvis guide, or rather the pelvis overshoot guide, into the space of the pelvis guide. And the reason why we're doing that is because the joint socket here is parented to the pelvis control, which is itself receiving the data of the pelvis. Gotta decompose. Where does shear go? Nobody knows. I mean, I do, but apparently Maya doesn't. All right. So now, there we go. Everything's lining up correctly, and I can go move this overshoot guide wherever I want. But it will move with, I believe I have it parented to the pelvis guide, so it'll move. That's not correct. I did something incorrect here, and let's find out what it was. Because it sure was not what this is supposed to be doing. We are getting a double transform here, and this suggests I may not actually be plugging the right thing into the inputs. Let's see what we've got here. Let's take a look at our pelvis overshoot guide. It's getting its world matrix. How about pelvis? Also world matrix. Shouldn't be seeing any double transformation if we're using world matrices. So I got to think about this for a second. This is the thing that I'm using to move the whole thing around. Yes, it is. And it's moving them all around, as it should. All right. So what was I doing that was causing the double transformation? Oh, sorry. I should have just undone that. All right. This works. How about just moving the pelvis? Just moving the pelvis works. Was I moving? Did I have both of them selected? Yeah, okay, I'm an idiot. That's what happened. Obviously, you get a double transformation if you try to move them both at the same time. Looks like this is actually working fine. All right. Let's see. There's the pelvis control. We need a chest control. And then the joint here can actually serve as our control. Again, great when you can remove complexity. There are very few things I like more than removing complexity in rigging. I mean, really in everything, right? Like, complexity is what you would like to avoid or somehow hide if you possibly can, right? Yeah, let's make another circle. This one's going to be the chest control. Also, I apparently can't type. No, I've been calling the buff these days. Now, what we need to do... Now, here's a question. Oh, right. We actually probably don't need to do that. Yeah, we don't, actually. I don't think. Let's see. Let me just think about this for a second. What did we end up actually doing here? Like, how is this being driven? The joint, right, it's the bone. Actually, the bone length is not being driven, which suggests that I'm driving something else. That's what I want to figure out. Maybe I actually never did drive this. Let's see. No, I definitely did. So... if this bone's length is not being driven, what am I driving? Sorry, we're stuck here in the... I, kind of did this a while ago and may have forgotten what I was doing mode now. Which is very embarrassing, but I don't know. Streams are, in a sense, ephemeral. Not in the same sense as ephemeral rigging, but in the sense that, like, if you kind of screw up, it's a stream. Yeah, what am I doing here? What am I controlling? Because obviously, if the chest is doing this, right, then something's happening to this bone. It's getting stretched, or its length is changing, right? Something's happening. Did I simply... Oh, I see what I did here, probably. No, I'm not driving the joint either. One second. Something in this hierarchy must be getting driven. Yeah, see, now we get to see what actual rigging is like, right? It's not this, like, you sort of... You may envision people just sort of envisioning what they want to do and then doing it. But of course, just like programming, half of it is like, wait, what did I do? And that wasn't what I meant to do, right?
Yeah, doing things live is always a little tricky.
It is actually.
I gave a talk a couple of years ago where I was demonstrating some stuff that I'd written to demonstrate what I was talking about. And somebody had a question about, well, what if you did this? And I had to do some live programming, like in front of about 40 people. Yeah. I have to tell you, it's really nerve-wracking.
Yeah.
So,
I mean, luckily, I'm not terribly invested in, like, people not seeing me make dumb mistakes. Or this probably would be really nerve-wracking. But in fact, it's just like, no, I mean, everybody literally makes dumb mistakes all the time. Like, that's how it works. But this one is actually kind of surprising. I'm like, what the hell did I do here? I maybe should have just made this from scratch instead of picking something up I started on, like, a month ago. Because very obviously something here is being driven. And in fact, here's what we should do. We should actually look at the graph and find out what it is. What is this stuff actually going out to? What is the chest stuff going out to? It's going, like, it's being decomposed and it's going into upper body. Oh, that's weird. What? Why would it be... I sort of assumed that was there for space switching purposes. Maybe I misinterpreted this graph. Let's see if I actually just screwed that up. I'm literally saying, where are the chest inputs going to? Chest inputs, here it is. I may have been looking at the wrong one. That would make sense. It's going into contour bone. Oh, okay. Here was my mistake. This was actually very silly of me. Usually, when something is being driven, you get that little yellow, yellow thing next to the channel. And indeed, its length is being driven, and that is exactly what I would have expected, and I was very surprised to see that that did not, in fact, seem to be happening. I mean, here it is, it's driving the length. Here's the thing, because it's not keyable, it doesn't light up yellow. So that was all me misinterpreting what I was looking at. I look over in the comments and I see, Nicholas Concave, eagle-eyed, did in fact notice, I think you were moving two things at once, all and pelvis, which I sure was. And that is a perfect example of, like, this sort of thing is never actually smooth. It's always confusing. You just look at it until you figure it out. But anyway, so this actually makes perfect sense. This is what's happening here. Now, what is true, though, is this may not be what I want to be doing. And here's why. So right now, much as I did for the finger, right? I'm driving each bone. I'm driving the bone's, standard length, right? It doesn't get any stretch, as it indeed should not, right? Because we are driving its bind position. We're driving its base orientation and everything. By the way, a number of new people have shown up in our watching this. I want to apologize to any of you who tried to get onto our stream yesterday. I accidentally set it to be scheduled for yesterday. That was incorrect. I meant today. I completely didn't realize that was happening. And so if anybody showed up and just was like, where's the stream? I very much apologize. That was completely my fault. So let's see. Right, here's why we don't want to be doing what we're doing right now. We are simply driving the bones, and we are not doing anything else to add an additional sort of control for the joint. Now, in the fingers, this is actually kind of what you want, because the fingers are FK. And if the spine were also FK, this would actually be completely correct, right? This would be sufficient, and it would be quite simple. And that is one of the things that you get out of Contour, actually, is that since you can treat your joints as if they were bones, and that's a perfectly okay thing to do, it adds a great deal more simplicity to your rigs. In this case, though, that's really not what we want to do, and the reason is this. I could, in fact, pull this thing around if I wanted to, like manually, like I could make this joint a control, but it is fundamentally going to be an FK one if this is how I'm choosing to do things. If I were to use the pelvis control and then rotate it, well, I would get FK behavior. That's what you'd expect. That's not what I want. But I also don't want to take the joint out of the hierarchy. And there's a number of reasons why I don't want to do that. Although, again, you certainly can in Contour. Contour is perfectly okay if you do that. It hasn't got an issue with it. But I don't want to do that. And the reason why I don't want to do that is, A, I want to drive the position of the bone CV that I have here that will eventually itself be a control, so that it maintains its relationship in between these two, is suspended in between the two, which will automatically happen if I use an aim, which is exactly what I'm going to do in like a second. One of Contour's aim handles. So what I want to be doing here, I still want to be doing all the things I'm doing here, because I do want the Contour joints and bones to have exactly or I should say the bones to be, in a sense, encoding the default, the bind values of everything. That's something that's quite nice that Contour does. Where because you have a separate length and stretch, I can have something in the control rig, in this case an aim handle, causing the bone to stretch, but that doesn't change the length value. The length value is its canonical length, and the stretch value is a multiplier. And that's quite nice, and I really like it. I want to maintain that. It just makes things very clear and simple. So here's what I'm going to do. I believe I can just leave everything I've already got in place, and it's not going to hurt anything, but I am going to add a aim handle. And in this case, I'm not going to use an up vector, because there's really no reason to in this case. Essentially, the aim handle... In fact, I believe our aim handles, that's right, our aim handles, unlike our IK handles, aren't a custom node. I'm actually just using Maya's aim constraint, because there was no need for us to write a custom node to do something the aim constraint already does. And it is basically just exactly as we described, using an aim at with none as the up vector type. All right, we are going to rename this to chest control. We are going to put it under the anchor as well, and we are going to drive its transformation, which shouldn't really have any notable effect on it at all, actually. We're going to drive its transformation with the chest input. Where were we? Right, we need inputs. Right. Yeah, decompose. I know I keep threatening to write code for this. It bugs me every time I have to do this manually. But I'm also trying to avoid doing that too much because I think it is less clear for people in terms of like what's actually happening. Maybe we'll do something that's like a different stream that's more code centric. I think that might actually be nice for those who are interested in looking at how one would, sort of script a bunch of these repetitive actions. All right, so we have our chest buffer. It is now getting controlled. What we do here should, this all still works, but now we can take our chest control, and that now behaves as one would expect. There we go. And you'll note that the bone CV is now, because this is how bone CVs behave. If you are correctly controlling the stretch, the length or stretch, and in this case it's actually been plugged into override stretch, since that is how aim handles work in Contour. If you're controlling the stretch and orientation of the previous joint, then you will get the correct behavior out of the bone CV. So the bone CV can simply become a control, and the aim handle essentially becomes our chest control. And we're going to put this back, which I'm going to do by undoing a whole bunch. If I ever forget that, it's actually not the end of the world. Like I said, there's no actual canonical arrangement of these things, really. So I can just put it back somewhere, and as long as it's like zeroed out, I don't really care if it's the exact same value in Y, But anyway, let's see a couple things. Add a circle shape. Sure. Whether this is actually an appropriate shape to fit any given character, I have no idea, but we're going to deal with that later. All right, a couple more things. We have to add a contour orient. To our joint here so that it will maintain its orientation. That part's pretty important, but that certainly seems to be working now. And let's go hide any channels we don't want people screwing around with. Don't want any blend in this particular case. And then we'll have a few more to do for the mid spine, which again can just be the contour bone CV. That all seems to be working fine. Last thing, let me get the... Don't need that to actually be a locator. There we go. All right, I believe we actually now have a working spine. We don't really need to do anything else beyond what we have done in order to get the deformation to behave correctly. This is contour. We don't need to have spline IK. We don't need to have like a bunch of other internal systems. If you did, we might well implement those systems as subcomponents in a componentized system. But we don't. Contour is just going to handle that for us, so we don't need to care. Let me just check and see if there's, like, is this actually working properly? Ah, it isn't. Okay, there was one thing that I did not quite get right. I guess how this ought to work. Let me think about this for a second. How do I want to do this? Here's the question, right? So in this case, in the case of the pelvis, if you're going to move around your overshoot guide, right, reasonably enough, it doesn't change the pelvis's orientation. You wouldn't expect it to, right? Now, in the case of the torso, the natural way, like following the same way that I've set up the pelvis and stuff, is that if I move this thing, it's going to change the orientation of the torso. I am not sure that I want it to do that. So in this case, I think the answer is going to be, I'm actually going to do something a little bit different. With the simplest thing to do is to do something a little bit different with the how this the guides, how the inputs get translated into what we're feeding into the bones and joints. Previously, what we'd been doing, which I generally like, is that we're driving the length of each bone and the next joint orient attribute in order to get everything oriented properly. With the occasional exception, of course, that we have like sort of free-floating transforms, like the actual chest control, that we are not, we are just simply driving directly, right? Let me just make sure I got shear in there. Yeah, I did. Okay, good. In this case, we're actually going to use that sort of direct drive directly on the joint. Because, as you know, you may be aware if you've seen other streams or used Contour, Contour really does not care about how it gets its CVs, right? Ultimately, this is a spline. It has CVs. They are being driven by the bones and joints, and it doesn't care how it gets that information. So we can just drive the position of this bone if we want to, this joint, sorry, and that is, I think, what the right thing to do is in this particular case. In order to do that, this is going to be quite simple. We really only need to be to care about translation in this case, so it's even simpler than previous ones that we have done. We need to get in the inputs. We need to grab this joint. We need to get the transformation of the chest overshoot input in the space of chest. We are going to do this the same way we've been doing it all along. We really only need to translate at this point. Aha! That is, and here's what's going on here. We're actually getting a double transformation. Because we're also, in addition to doing this translation, we're also driving the length of the bone. So what we actually need... let me think about that for a second. Because, of course, the bone really shouldn't have zero length. Like, that's I don't really know what happens if you do that. And it doesn't seem right. Like, it's not a good description of the system if a bone has zero length. But we do basically want this thing to sort of be free-floating. I may detach it from the bone. Because, of course, again, this is a thing that you can do in Contour. We don't actually need it to be driven by its bone at all. We generally have, a bone in between each joint. It is very advantageous to do so because of everything I was talking before about how it gives your rig sort of this clear structure, but it is in no way a necessity. I can take the joint off the bone if I want to. I can, in fact, completely remove the bone if I want to, which I'm going to do. And this should all continue to work. Yeah, see the joint. No, I should not remove the bone. What was I thinking? Because then you don't get any drawing, and I want to see what it looks like.
Yeah, I was actually gonna say I don't think that's the right thing to do most of the time, is it?
No, it's actually not. I don't know what I was thinking there, but now we have something that works. You can move this thing around. You can position it. I mean, this would be a weirdly asymmetrical character, but you can also position this for your overshoot. You can position this for your overshoot in this direction. You can position this if you want the spine to be curved in bind pose. That is all doing what it's supposed to do. So last thing we are probably going to do this session, let's add this spine to our body. Let's add this spine to our body plan. One moment, though. Before we do that, actually, I want to take a look at these inputs again. Because I think there are some that we don't need. For instance, we don't actually need probably upper body an upper body offset or um, character. I think that when I made this, I was still firming up how I thought about how the system would work. So I'm going to get rid of them. But again, here we really have to use code because there isn't actually a way to interact. Can you delete them, though, in the UI? I'm not sure. Regardless, this is how I would normally do it. Here's an attribute. We're going to call it character, because I'm pretty sure that's what it's called, because I would have done this camel case. Dot delete. I think that's it. Yeah, there it is. Yeah, we don't need upper body and upper body offset, because the angle
Raph,
will... Yes.
is your script editor on the monitor that you're streaming?
Oh, I'm not. I'm typing in the command line.
Oh, okay. I just couldn't
Yeah.
even see that. Okay, my eyes.
Oh, yeah, no, it should be, like, right there at the bottom.
Gotcha. I understand. I thought you were typing maybe in an off-screen script editor, so sorry.
No, I'm not. Oh. That is obviously wrong. There we go. Let's see. Are there any that we... Oh, yeah, upper body offset. We don't need that. I thought I would have done it like that, but maybe I did not. One of the things I do not love is the fact that the attribute editor consistently lies to you about what your attribute names actually are. Yeah, that's what I did. All right. All right, now let us bring this in to our standard biped. Here we have an arm and some fingers. Let's bring in a spine. Now, in order to, we now that we have set up both the arm and the fingers with these, like, move the whole thing controls, that's what we're going to use to reposition the whole thing. Although, one could argue, and in fact this probably is the right thing to do, that we should take all of these guides, not all of them, not the arm obviously, and we should actually parent the finger guides to the hand guide. Yeah, you can't actually. I forgot about that. Never mind. If I want to do that later, there's a way around that issue, but I'm not going to worry about it right at the moment. I selected the wrong one. What I actually wanted... Oh no, I never did do this for the arm. Well, I'm not going to worry about it. I'll just move them all manually. We fix it later. I just want to sort of show how this would work. Right. So here's our arm. Probably more or less kind of where it would be in a body plan. Right. It should be above this top spine control because this is actually something that I often find to be true. Like, sometimes people do it wrong, but I think it's pretty important, is that if you're doing a spine like this, right, if you're doing a spine that isn't exceedingly anatomically accurate, end it at about a little beyond the bottom of the rib cage, because the rib cage is solid. And if you have the spine, as people sometimes do, a like completely flexible spine, like all the way, in either direction, going up to like the base of the neck almost, which you do sometimes see, it looks super weird, right? That's not how spines behave very much. Now, obviously, this isn't... If you're going to do something that's actually like an accurate simulation of a skeleton, of course, you do have vertebrae there, and they do actually move. But at that point, you're doing something really very different from other types of rigging, actually. Anyway, let's drive an anchor. And once again, I'm going to do it manually. Right. Oh yeah, we should throw these guides and components where they're supposed to go. Let's grab the spine inputs and outputs. Oh, that's right. We didn't set up any outputs for the spine. We need to do that. Because otherwise this is really not going to do anything useful. Let's see. We've got as possible outputs, because I don't think we don't care about the in terms of outputs, we don't care about the overshoots. Um, we have pelvis, mid spine, chest. Yeah, that's all we've got actually. That's all we need. Is it, yeah, I never remember. Is it data type or is it attribute type? Because it might be one or the other, depending on what kind of attribute you're making. Oh, also I was selecting the wrong thing, and also I forgot to grab the first item in the selection list. Yeah, I did not like data type as a flag. Let me just actually check if I just typed it wrong. Yeah, I think that might be Campbell case. Yeah, there we go. Yeah, there we go. We've got a pelvis matrix attribute now. And we need to hook all of that up. Oh, this is still called contour bone CV. That is not a good name for a control. Oh, and I also didn't hide any of these other attributes that I don't actually want. Only translation is relevant for this mid control. Well, that actually doesn't necessarily have to be true. If we actually use transform twist, I think I'm going to keep it that way for now. We can change it later if we want to. Let's see. I'm going to call this mid spine control. There we go. Let's see. Right. We need to take its world matrix. There we go. So now this should work. We've got spine inputs, but we also now have spine outputs. And we're going to plug that into the anchor inputs of the left arm. Let's hope I actually set this up correctly, because I honestly don't remember if I did or not. And if we didn't, well, you can fix it pretty easily. Right, so we can grab this is going to be the chest. Right, here's the chest input going into the anchor offset, and the chest output going into anchor. Here we go. This should work. So this should mean when I move the chest around, aha, there we have it. We see the arm working with some IK. So I think that is the where we're going to leave it off for now. Next time we will probably deal with a couple of questions. One is making these reversible. Like I said, I don't want to have a different version of each of these for the left and right side as one might have had. Like, that is one way that people have approached this. And I really hate that, right? I don't want to duplicate myself. I want to have one component file that defines how that component behaves and what it is under all circumstances. So we need to make them reversible, and then uh, the next thing that we will need to do, I think, is to deal with space switching and how you essentially deal with passing in much the same way, but it's basically the same concept we're using for the anchor. You can think of the anchor as being a space that we're just always gets applied to the whole rig. But you need to do space switching. When you need to do space switching, you're essentially doing a fairly similar thing that only is going to end up being used by some aspect of the rig. And it's up to the component to choose how it wants to use the spaces available to it. So, anyway, yeah, I guess I will before we sign off, sort of throw it out to anybody who is watching. Do you have other questions that you'd like to ask about what we're doing here? I'm also happy for the opinions of cats. I take their opinions very seriously.
Yeah, I unmuted for a second and then, yeah, there's a talkative kitty here.
Yeah. My cat also has many opinions on things.
Yeah, so I think my cat has the opinion that food would be in order at this point.
Nicholas Comcave, I hope I'm pronouncing your name right, says cat abides, which is surely true. But it sounds like unless somebody has a question, it sounds like mostly that's not the case. So please come back next week when I will surely have done this correctly. We've actually had a string of minor snafus. I didn't put up the stream last time until real late in the day. I should do it days beforehand, right? And then this time I got it on the wrong day. So hopefully next time I will actually do it correctly. I would appreciate that. That seems like it would be a good idea. We'll see if I succeed. But anyway, regardless, unless I manage to screw this up again, I will see you guys next week, same time. It's always Tuesdays at 5 right now, and regardless of what YouTube tells you, if YouTube tells you otherwise, YouTube is lying. We will proceed from there, and I think it will not be 2 more sessions. Sorry, not a specific number. I didn't mean to say 2. Too many more sessions until we can actually rig a character with this, because honestly, the most complex part of it is going to be doing the leg, which is a little more complicated than what we've done because it's going to have a reverse foot rig. And essentially, that's the only complex aspect left. I mean, we got to make them reversible. We got to pass some things through for space switching. And I guess we have to make a head, but I mean, that's going to be quite simple. Heads are not particularly complex rigs. I mean, faces are, but heads are not. And yeah, I mean, I could easily see us in a couple of streams being able to like actually go and rig a character with this, which again, it's like compared to like if you were to write an auto rigger that had a similar sort of structure, like a modular component based structure, quite a common thing to do with an auto rigger, right? It'd be probably weeks of full-time work before you'd see the ability to actually generate a full usable rig out of it. And that's one of the other things. I mean, that is not maybe the most critical thing, because it's like in the lifetime of, say, a feature film production or something, right, a couple of weeks is nothing, right? It's not very relevant. But A, sometimes auto riggers actually take a lot longer than that. B, even if it's not the most critical aspect, I think it comes out of one of the things that is really critical, which is the simplicity of the system. There are some ways in which what I'm doing here and the way that we do it in the Maya node graph hides how simple it is. Like, it still kind of looks kind of complicated with the graph and stuff, but compared to what you are usually setting up for a rig, and part of that is Contour, right? Because Contour makes things much simpler. Contour sort of like does a lot of the things you'd normally have to make subcomponents or something in order to actually achieve. So that's actually a big part of it, right? Nevertheless, it is also true that even if you were doing all of that stuff, it would be much simpler to do it in a componentized way than to write than to write an auto rig system that was well designed. I mean, it's relatively easy, and I say easy in quotation marks, right? To write an auto rig system that's very brittle. It's still hard simply because trying to translate what you want, how you want your rig to behave into a list of operations to generate nodes for is actually like kind of takes something that's relatively simple and makes it complicated in a lot of cases, right? Like if you had to express what the rig was doing just as code, as functions, that would be much simpler, which is part of the problem with auto rigging, right? But anyway, my point about this rant is the fact that we can do it this quickly by itself isn't necessarily like the most important aspect of this, but it is indicative of something that I think is really important, which is that the system is actually both a lot simpler to reason about and to deal with, and very transparent.
Yeah, there's actually a really strong analogy there with some
Yeah.
stuff with code, right? Which is there are definitely times when I will spend more time trying to write small code than it would have taken to write large code, right? It's not
Yeah.
even that it's a time saving initially in writing it, but you wind up with a lot less code to maintain, and hopefully you wind up with much simpler code because a lot of the time it is finding those simplifying assumptions that let you write the smaller code. And in the long term, you're going to have to live with your code probably for a long time. You're going to have to modify it. People are going to have to understand it, and so it's not so much the upfront time savings that matters, right? It's the
Right.
fact that you have a lot less code and that it's simpler.
Exactly. And the thing about your sort of conventional auto rigging is that if you try to do it really quickly, it's going to become unmanageable very, very, very fast, right? And I think it says something about this that you can do it quickly, and just sort of without putting it into a state where further modifications to the system or further components for the system would quickly become sort of like an unmanageable thing that would, in some cases crash and burn, right? Because I have seen that happen with many auto rig systems. But in any case, yeah, I think we are done for today. And please tell all your friends that they will learn invaluable rigging information and information about really important tools if they watch the Notional Pipe streams. And I will see you guys next week.
Yeah. Thank you all for coming
Yep,
by, and thank you, Ref.
no problem.